Hello, my name is Jeff Shelton. I'm president of Dracion Corporation, which, by the way, is a made-up name. First company I had was Drayton Corporation. Second company I had was Halcyon. So why not combine the two? But Dracion's one of our focus is SCRs, and we think that with the alliance that we've built with some of our teammates, especially IGS, that we really do present options and solutions to solving SCR problems that no one else does. This webinar is to illustrate some of these, and at the end we'll give you the name, my phone number, and my email address, so you can contact us at any time. We're eager to talk to you about it. I'm going to tell you what, there's one fact that we can never get away from, that when your catalyst builds up with ash, you lose DNOx performance. You have higher pressure drop, a higher ammonia slip. And so the key to improving your SCR performance is to keep your catalyst clean. And oh yeah, by the way, typically catalysts now in coal power plants last 2 to 3 years. We think you should get 6 to 9 years. And if you follow what we say, we will guarantee that. So I want you to know that we don't have any secrets on what we're doing. We on how to solve your problems. What it is we term it as follow the science. And I guarantee you, if you follow the science, the science will tell you, keep your catalyst clean. And how do you do it? You keep your catalyst clean with LPA screens, air cannons, catalyst screens, and sonic horns. Keep your catalyst clean and remove a lot of DNOx, and take that big expensive black box and make it your friend. One of the things that we did is we've identified 6 functions of following the science. One is to install and maintain your LPA screen. Number 2 is to solve your flow problems. SCRs have many flow problems, especially now that you're beginning to swing load your boilers, so it's only getting worse. 3, I wonder why we say this, install air cannons. We're big believers in air cannons. 4, you have to maintain all of your online cleaning equipment. That's not just the air cannons, it's also the sonic horns. Some people think that I install sonic horns and I never touch them and they always work. Well, the low maintenance requirements and no maintenance requirements is different. You have to fix the sonic horns on occasion. And the 5th one is, people think that you can solve all your problems by going to larger pitch catalysts. We'll discuss that, and we really don't believe that that's the solution. And plants are paying millions of extra dollars just trying to go to high pitch catalysts, which isn't going to solve the problem. And then finally, I like to say it is do the little things. And one of the little things is getting a good catalyst screen. IGS makes a cat flow screen, which improves the performance of your online cleaning equipment, as well as improving your flow. The first thing is that, years ago when SCRs were first introduced, they didn't put LPA screens on. Why? Well, because really LPA was misunderstood there, and it's still misunderstood, but maybe not quite as much. But IGS is specialized in LPA screens, and really we are the market leader in LPA screens. And why are we the market leader? Well, one is because the replacement cost of your screens are almost non-existent. Why? Because you don't have to replace them. We've had some installations been in for 10 years. 2, we've learned how to install them so where it's a very minimum pressure drop. And 3, and very important, is an LPA screen is a flow aid. And so we install the system so where it not only eliminates LPA from reaching the SCR reactor, it improves the flow. And any flow improvement you can have is a great thing. Now, when SCRs, again, when they were first introduced into the coal power market, they weren't included. You can have an upset condition and produce LPA maybe 2 hours worth of upset conditions. But the LPA gets into the SCR and then ash piles on it, and it's maybe a small fraction of the time that you generate it, but you pay for it for a long time, and you pay dearly for it. On the left side, we show a picture of popcorn ash, and that's what people think LPA is. Popcorn ash, which is combustion generated. For instance, deposits knocked off by your soot blowers. If you have pluggage problems in your boiler and you're knocking a lot of deposits down with your soot blowers, you're probably going to have LPA. One of the words I saw in the RFQ was the ash cascading from the turning vanes. You get a lot of buildup on the turning vanes, which impact the flow, but then it reaches a point where it falls down on the catalyst and it's just a big pile. So it's all about just follow the science and being smart. People have stopped performing maintenance on their LPA screens. And so you get giant holes in the LPA screen. So once where you had no buildup in your SCR because you stopped the LPA, because you haven't performed the maintenance on the LPA screen, you're now getting buildup. Keep your LPA screen intact. Replace the panels that need replacing. Be smart. It's not a lot of money if you take a proactive approach to it and solve the problem. This is a video that shows the LPA screen cleaner. LPA is obviously going to get stuck to the LPA screen, right? It's smaller than the catalyst opening. So it's like, really? You don't think it's going to get stuck there? Yes. SCRs have flow issues. You have flow issues where, I can't emphasize enough that even flow distribution is different from ash distribution. They're different. Many people have that where they make the turn, the front wall, the ash falls out and overwhelms the catalyst, and boom, you have buildup problems. You have to fix the flow problems. The flow problems are not only the entire reactor, but horizontal duct runs and turning vanes. And air cannons can help it. On this screen, we show a horizontal duct, which they say on low flow builds up, and then on high flow, it sweeps the ash off and overloads the catalyst. Well, you can address it in two ways. Keep the buildup off that duct, or put air cannons down on the air below and sweep it off then. Both methods will work, and it also shows that the 6-inch monster nozzle CFD is a monster. It is a monster. It will clean up to 30 feet. This is a photo of an installation of an air cannon, and look how simple it is. Now remember, a lot of us from Dracion and from Alabama, so simple is good for us. We like to keep it simple, but just look how simple it is. Everything's accessible for maintenance, and you have one air cannon instead of 8 air cannons. Let's keep it simple, let's keep it reliable, and let's clean some ash. But you go, why do I need an air cannon for my SCR? I mean, there's been a lot of SCRs built without air cannons. Well, yes, they're absolutely true, but there's a lot of SCRs with buildup problems. And I will tell you that a lot of the newer ones have been built with ash sweepers, because people recognize sweeping across the catalyst is much better than blowing straight down into it. What do you expect from an air cannon? Well, number one, I think you're going to double, maybe triple your catalyst life. That's a lot of money. Number two, you're going to lower your pressure drop by eliminating buildup. 1 inch of pressure drop is, $200,000 a year. So it doesn't take much to make that pay. But more importantly, and when this happens, I cannot tell you how many times plants run at a reduced load, they get the buildup, and so then they try to ramp up their boiler load, and they can't get to the boiler load because of their NOx. So they have to derate their boiler. When it's time to make money, they can't make the money they can because their SCR is limiting them. Stop it. Eliminate the buildup and bring your boiler up to full load when you have the ability to make money. And one is very simple, and it's kind of gotten lost lately. At the first, when we first started selling them, it was big, but we kind of emphasized other issues. But plants are paying as much as $500,000 an outage to manually clean it. Well, let me tell you what, if you don't have the ash there, you don't have to spend $500,000 to manually clean it. So you can pay for the system in 3 months just by saving up to $500,000 in manual cleaning. But one of the problems with that big pile of ash is it takes days to cool so you can vacuum it. So it extends the life of your catalyst. Many times the SCR is the critical path of an outage. Reduce your outage, which is really big. So all told, when you add it all up, many times the investment on an air cannon system for an SCR can be less than 1 week. I did not stutter, 1 week. Now, as we've gone around and installed air cannons on SCRs, there's been a real learning curve. One is that in many cases, a 4-inch air cannon just doesn't clean enough. A 4-inch air cannon cleans maybe 1.5 rows, where you need 20, 30 feet to clean. But a lot of that is because we used nozzles that were designed for other applications. We just made use of the existing nozzles. Pay attention to the nozzle you use. The nozzle is so important. But then we used to line them up on line of sight. You can't line of sight nozzle, because if it's down, you destroy your catalyst. If you point it up, you miss the buildup and you don't get the performance. And also, we also really believe that volume is really important. And we'll show you a video in a little bit about how a 70-liter cannon moves 13 pounds of ash, and a 300-liter cannon moves 50 pounds of ash, and it could move more if we did more testing. But you also have to pay close attention to the seals. A lot of people have gone to these TP seals. TP seals and air cannons don't like each other. It limits the cleaning performance of it. But then again, catalyst screens, simple. Most catalyst screens on most catalyst OEMs are overlooked, and so they put as cheap as possible. But a catalyst screen can improve your online cleaning and improve your safety, and can reduce your time during an outage, because many people do not vacuum between the screen and the catalyst. So you have to have a screen that's easy to move, so you do that. That is 100% critical. Always, always. If you open up your reactor, you always vacuum between the screen and the catalyst. This slide shows this was one of the most troublesome SCRs I've ever dealt with. And so most of them don't have this problem, but we swept with standard 4-inch cannons, we swept the first module free. But then we had to come back and add additional module cannons to get into the center. So you have to clean the whole thing. You can't just clean it. And a 4-inch cannon doesn't really do it enough. And a lot of people say, I can't do that because I don't have access. The air cannon's going to be too far away. Wrong. This slide is a video showing where a cannon 50 feet away with 2 90s, and it is more powerful than what you have. Guys, when I tell you volume is important, believe me, seeing is believing. This shows the Martin Smart nozzle, which is a good nozzle. I'm not going to take anything away from it, but what it's designed to do is clean a short, fat area. You don't need a short, fat area. You need to be able to clean further distances. The IGS Monster nozzle, which is available in both the 4-inch and the 6-inch, cleans a focused path. It will clean, a 4-inch nozzle will clean double the length of a Martin Smart nozzle. A 6-inch nozzle can clean up to 30 feet. So it's a big difference maker as long as they're installed right. This slide shows the characteristics on just how important flow is and the peak force, which is pressure. So the 6-inch cannon, which is becoming the cannon of choice by me in most SCR reactors because you can clean the entire reactor. Some reactors from one wall, most reactors from two walls. You clean the entire reactor. But it has four times, I'm not stuttering, 4 times the flow. Flow and velocity is what determines it. The next slide, this slide, it shows a calculation of the nozzles. The multiplier nozzle is 50 feet away, but because of its nozzle and the ability to convert pressure into velocity, at 3 feet, the system velocity is 1,500 feet. 1,500, that's smoking. The traditional fan jet is at 3 feet at 400 feet per second. So based on higher volume, 300 liters versus 70, the multiplier system has 8 times momentum and 60 times more kinetic energy at 3 feet. The kinetic energy which is the definition of movement of energy by definition, is so much more because you have such a higher velocity and it's squared. But what does the science say? And I mentioned it earlier, and this is a picture of a nozzle that was installed downward. Woo! Catalyst manufacturer likes that because you ate the catalyst up and they're going to have to replace it. But what we did is we came in there and realigned the nozzles to get that. But the picture on the left shows what happens if you point it down. The picture on the right is if you put it parallel, where it sweeps across the screen, high pressure on the bottom, low pressure on the top, it takes off like an airplane. So it doesn't clean enough, even though it has enough energy, because you're not following the science. You're creating an airplane. What you need to do is to raise the nozzle up a little higher and tilt it downward so you can get the best of both worlds. The next slide shows what happens if you have a bad seal. 2 degrees out of spec nozzle orientation with a catalyst screen. You can kill the velocity when it comes past that first module. It hits the seal and it deflects up or down, killing the nozzle, killing the catalyst, or just going sideways. If you install them right, that's not an issue. Now, again, follow the science. And this is a video that shows the difference between a 70-liter cannon and a 300-liter cannon moving sand. Sand's not fly ash, but I think it's pretty comparable. Now, this slide, if you really think about it, this is one of my favorite slides, because at the first blast, you show the 70-liter cannon. It takes 0.185 liters of air per pound of sand. Okay, I have no idea if that's good or bad. I just know that it moved 13 pounds of sand. But the Big Blue 7-inch at the same pressure moved 0.166. So in other words, this has 2 90s and it's back like 5 feet. So you would expect the force to be less. But at 0.166, it moved all 50 pounds of sand. Why? Volume. And if you reduce the pressure at 4 bar versus a 300 liter, moves almost double the sand that a 70-liter cannon does at 7 bar. Pressure is so important, but so's volume. Pressure is where you break the initial bond, and volume is where you carry it away. Now, I've shared data with you on the 4-inch cannon. Ha! It's boggling what an 8-inch cannon will do. It's just, an 8-inch cannon, for instance, has over 5,000 pounds of potential peak force. A 4-inch cannon has like 1,150 pounds of peak force. So it's not what you start with, it's what you end with, and it's monitoring and knowing what you're doing to get the most. If you use proper alignment of the nozzles, all you do is clean a bigger, wider area, and you're much happier with the performance. We do a lot of videos, and we'll show you a lot of videos, but we also do CFDs, and this is a CFD that we installed on a ductwork. And the problem is that the ductwork's not long enough for the nozzle. So we get a lot of wasted air because of the nozzle will clean up to 30 feet and we got only 20, 25 feet of duct that we have to clean. And this is, what's the science say? And I've mentioned it before, you have to be careful of your catalyst seal. This is an installation from the inside. So where you can see that they place the nozzles at certain distance where each nozzle should have been in between the middle of each of those TPs if you're not going to remove them. The TP seals like in this picture limits the cleaning. I can't tell you how many times I've heard people say, all I have to do is go to a bigger pitch catalyst and my pluggage is gone. Brother, have you ever looked at your rectifier and see that builds up? Maybe it doesn't build up as fast, but it still builds up. I guarantee you that all catalyst builds up. Plate catalyst, honeycomb catalyst, dustbuster catalyst, corrugated. We believe that corrugated catalyst is the best because it has the best of the world from the honeycomb versus the plate. And with the corrugated type catalyst, we'll offer 6-year guarantees. Now, this slide is a slide where it shows where with the air cannons, the pressure drop is level, no buildup. The other side is no air cannons, and you can see, whoa, a lot of buildup. It's an absolute testimony that you need air cannons. A lot of people think, well, we made a mistake going away from steam soot blowers. Are you kidding me? Are you kidding me? Soot blower blows straight down. Think of your catalyst as a hopper. If you have too much material to go in the hopper, it's going to plug, and you're not going to force it down from the top. Blowing down packs the ash and is a problem for the catalyst. We recommend against blowing downward on the catalyst. And if you think about it, think about how much less ash you're moving each time with you blowing with an air cannon. A soot blower you blow once every 12 hours. An ash sweeper you blow every hour, and there's a bunch more of them. So you're moving a lot less ash each time, and it's not nearly the upset condition as the air cannons. The soot blowers. And oh yeah, by the way, people have trouble with moisture in their soot blower, whether it's steam or air. It's just a problem waiting to happen. We highly recommend against soot blowers. And if you follow the science, not only can we improve your SCR emissions, we can do it and reduce your operational costs. Plants are spending money they don't need to. Why not get with the program, save money, and double the life of your catalyst? Hi, my name is Jeff Shelton. I'm president of Dracion Corporation, and I want to tell you one thing about Dracion Corporations. We love air cannons. We get up in the morning thinking about air cannons. We think about air cannons all day, and we even dream about air cannons. And our goal with air cannons is to reduce your cost and improve your cleaning. We are the air cannon experts, and we will lead you to the promised land by following the science. If you follow the science, it's all very simple. Have you ever thought about your air cannons? A lot of people just think they're necessary evil, and so they don't put a big enough demand on the performance of them. Air cannons are purchased to eliminate the unsafe, inefficient, high-pressure water washing or car waxing. And the nozzles are a big deal. The nozzles focus the blast, and they make the air cannon perform like they do. For instance, most air cannon nozzles do a short, wide blast. Do you think Follow the Science says if you want to move this hard buildup, you need to decrease the velocity? No, it's going to tell you to increase the velocity. We want to give you a nozzle that increases the velocity, which leads directly to better cleaning.
You can install these nozzles on your existing air cannon and you can improve the cleaning. We believe that by putting it all together, we're innovative compared to our competitors because we're showing you what you can do by following the science. You're going to hear that a lot from us. Follow the science equals success for you.